Hi everyone. So I'm Alana, so we said. I'm here today, a COP26 special. Unfortunately, won't be anything about climate change because that's not my industry, but I am from Glasgow, and I am Scottish, as you'll tell from my accent. One of the main things that we are very proud of as Glaswegians, as well as Irn-Bru and Haggis, is also our shipbuilding industry. Shipbuilding in Glasgow is a really strong, deep-rooted part of our heritage. It's been around for hundreds of years. From the 1700s, Glasgow was regaled worldwide as the centre of world shipbuilding. Since 1712 up till now, we've had over 300 shipbuilding companies in Glasgow working on the River Clyde at any one time. Sorry, over the course of that time, with up to 30 to 40 yards at any one time in operation. Produced over 25,000 ships on the Clyde. So you can tell from that we're pretty good at what we do. There has been a massive decline since then, but I am lucky to be part of one of the remaining shipyards in Glasgow. That shipyard being BAE Systems. So BAE Systems is the company I work for. You may have heard of them. We're a major defence company, primarily based in the UK. And we deal with supplying defence tech to the MOD, the Ministry of Defence mainly. We supply amongst a lot of things. We supply Eurofighter Typhoon aircraft, we supply CV-90 armadillo tanks, we supply cybersecurity, astute and dreadnought submarines, and what I'm here to talk to you about today is a selection of Navy warships. If you want to slide on to the next one, Sophie, please. So, BAE Systems Naval Ships is the company that I work for. It's a division of BAE Systems within Maritime. We are based in Glasgow on the River Clyde between two shipyards, Govan and Scotstoun. And our primary role is to design, manufacture and commission or test all of our past, present and future Royal Navy vessels. I'll talk a lot more about that later, about what we do specifically. I don't know if any of you are James Bond fans. If any of you have seen the latest film, No Time to Die, we were lucky enough to have one of our own ships featured within that film, HMS Dragon. She is one of our Type 45 destroyer vessels. In the bottom left-hand corner there, you'll see a picture of another of our Type 45 vessels. It's not Dragon. Dragon's easily identifiable by the big beautiful picture of a dragon that's painted on the hull side at the forward ends. This is another one that we've got. On top of the Type 45 destroyers, we've also built aircraft carriers, big aircraft carriers, which is the centre photo there. These are essentially our large island vessels that sit in the middle of the sea and act as aircraft pit stops for the air forces of our nations. They will land aircraft, refuel, resupply, and then they can take off again from our runways on the top deck, flight deck. We can take up to 40 aircraft at any one time on these, and we can embark up to 927 personnel. So they are big ships, big ships. Additionally, we do much smaller vessels. So on the bottom right-hand corner there is our river-class offshore patrol vessels. These are coastal vessels. They're mostly used for coastal patrols around the UK. We also take them out to the Caribbean, the Mediterranean for humanitarian relief in the event of an earthquake or stuff like that happen. We can use these ships to go in and provide rescue support and relief. If you want to go to the next one, please, okay? So currently within the business, the project that I work on is the Type 26 Global Combat Ship. That is the main ship that we are working on just now within the Glasgow sites. The Type 26 is a frigate design. If you've ever played battleships, it's it's medium, so it's slightly smaller than a destroyer, but it's bigger than a little patrol vessel. But it had a vast array of complex technology integrated within that ship to allow it to do a whole range of operation options that the Navy would request. It's a successor to the Type 23, which was the last frigate design that we built. It's an anti-submarine warfare vessel, which means that it has been specifically designed to be very, very quiet. And that means no drying your hair, girls, or boys for that matter, no running, no having a shower, no cooking anything in the microwave. Whenever we go into an ultra quiet state, whenever we are at risk of submarine attack, the ship is able to go into a very quiet state that prevents us being detected by submarine sonar systems. That's a unique part of its design, and one of the reasons why the Type 26 is one of the most advanced naval vessels on the market currently in the world. And that is one of the reasons also why we've been able to win contracts for not just our Royal Navy. We've been building 8 ships for the Royal Navy, for the British Navy, but we're also supplying the design of these vessels to the Australian Navy for the Hunter class and Canadian Navy for their own ships as well. So it's a very successful design, and we're currently in build of the first ship. This picture here you see is HMS Glasgow, our first of class, which is currently being built in Govan in Glasgow. That's us bringing the 2 aft and forward blocks of the ship together to weld them to form one complete hull. So what we do in order to get to the state of having a fully complete ship handed over to the Navy is a number of things that involve a lot of people to get the job done. If you can slide over to the next one for me, please. What we do is we take a concept, so a preliminary idea of what we want the ship to be, and all the requirements that come with that concept that we need to meet. And to get from there to the end product, we have over 3,000 people within the BAE Scotland sites working on the programme, who work on design of the system. So from a paper ship, we draw schematics of piping systems, we look at component integration, all manner of electrical integration. We then build parts up, we then put them into a detailed design model. So the company currently has a lot of advanced tech that we're trying to implement within the design phase of shipbuilding now. You'll see here we use VR technology and we use our visualization suite to get us to a point where we are content with the build. The visualization suite in particular is something I've had experience from. It's a very cool piece of tech. We have a 3D model within a software program of the entire ship. So everything from every single deck, every single compartment, every single piece of equipment and part, pipe, cable within that compartment is modeled into an entire whole ship model. We can use the visualization suite. You can put on 3D models there that you can see in the photo, 3D goggles, and open up any compartment within that ship to immerse ourselves within that compartment. We can walk around the compartment, move parts about, check if there's any clashes of pipe work with anything, or check that the electrical cables aren't near hot equipment. We check all manner of safety concerns, operational concerns, to get us to a position where we're content with the design. That software has given us a huge advantage in getting us to a very mature stage of design before we then start the build. Now the top right photo here is us in the build manufacturing stage. Now, given the enormous size of these ships, we have to break them down into bits and build them in blocks. And the unfortunate aspect of working in a shipyard in Glasgow is that we can't always rely on good weather. So we break these down into blocks and we build them inside our warehouses. Once we've finalised the block steelwork, as much as possible, we bring it out onto the hard stand, which is just the open area in front of the outfit halls, and then we bring the blocks together, as you can see there, and we weld the entire ship together. So it's essentially a big jigsaw of individual parts that we bring together to build an entire ship. Obviously, you're here today to learn a bit about what engineers do, so I'm now going to talk a little bit about what it is that I do. We move on to the next one, please, Sophie. So, as Sophie said, I'm Principal Mechanical Engineer at BAE Systems, and I work within the Power Propulsion team. I'll talk a little bit more about what that involves in a wee second. And my responsibility is the shaft line system, which is everything from the propulsion motor right down to the propeller at the aft end of the ship. To get where I did today, I started off when I was your age in school. I wasn't entirely sure what I wanted to do. Definitely talked about being an artist or a sports person. I thought that was something that would bring me a lot of money. I did know I was good at maths. I really enjoyed physics at school and loved solving problems and working out how things work. That led me to apply for a few engineering degrees in Glasgow. The one I eventually went on to do at Strathclyde University in Glasgow was in mechanical engineering, which is the study of all things mechanical and aero-based, so aircraft design. I was very fortunate enough to experience a lot of opportunities while I did my degree. I studied for my third year of university in Australia, which was great. And then in my final year, as part of my group project, our project was to participate in a design and build competition run by the American Institute of Aeronautics and Astronautics, I think. I can't remember it well now. So the bottom photo there is actually a picture of me in my fifth year university in Arizona in America with the model aircraft that my team built. We had to build it to a specification that was written to allow us to compete in a number of different challenges with that aircraft. So there was speed, endurance, how much cargo could we carry, how much maneuvering could we do, turning in figures 8, that kind of thing. So this was the final design that we ended up building, and we took that plane over to Arizona and competed in the competition, which was an incredible experience, one I've never forgotten. In my final year as well, I was also applying for jobs. I was applying for everything in aerocraft industries, automotive industries, energy, and I eventually landed myself with a job in the mechanical engineering graduate scheme in BAE Systems. So I've completed 2 years on my graduate scheme, and I'm now in the position that I am today as system lead for the propulsion train. And this year I was also lucky enough to receive Young Engineer of the Year from Scottish Engineering, which is where I was fortunate enough to meet Susan, who got me involved in this. So that was a very exciting moment in my career to be awarded that. And the reason that I've got that is for the work that I do within BAE Systems as an engineer. So can you slide on again for me, please, Sylvie? So what I do as an engineer, as I said, I'm responsible for the propulsion system or parts of the propulsion system on the Type 26 design. Because everything's top secret in BAE Systems, we work in a very secret environment because it's to do with the Navy and defence. Unfortunately, I can't send you any photos of my ship specifically, but I have put up a number of pictures here, which give you a little bit of an idea of what a propulsion system looks like on a ship. So the centre picture here is an example of a propulsion system on what's probably a shipping container or large cargo vessel. On the right-hand side of the photograph is an enormous diesel engine, which is effectively your power. So it's the equivalent to the engine in your car. Then immediately left of that is what I imagine to be a gearbox. Similarly to the gearbox in your car, it will change the speed at which the shaft rotates relative to the engine. And then down the shaft line, so connected to the gearbox is a shaft line that transmits rotation from the engine down to the propeller at the aft end, which is on the left-hand side of the photo. The propeller is what generates the forward thrust and makes the ship go forward in the water. So my job as engineer is to establish a position for all. So the shaft line itself is supported along its length by a number of bearings. So in the photo here as an example, the centre one, the bearing is the middle green block. And then where the shaft transitions through the ship, which is the red section at the end, there's 2 yellow liners on the shaft At the aft and forward end of the ship intersection, these are also bearings. What I have to do is establish a position for those bearings relative to each other along the ship, which allows the system to operate successfully to the performance criteria that we said to the customer that we would give them. And the way we do that is we perform a series of complex calculations and models, and then when we go to ship, we will project a laser line. So we set up a big laser from the propeller. When the ship's shaft's not in place, we transmit that laser right up to the engine. In the bottom right-hand corner there, this is what's called a spider. So we place a spider in the center of the bore of the bearing. That spider has a little glass plate in the center, which allows the laser to pass through it right through to the end of the line. And then we move that bearing position to achieve a certain offset of position relative to that laser line that's going through the center. And then once we fix all those pieces in place, we can then fleet the shaft in and connect it all up. And then we would set it to work. So start running the engines and make sure that we generate the correct thrust to get the top speed that we've said to the customer we're going to get. I've done a lot of amazing things in my job. Just working on a daily basis with these ships is really incredible. You get to work on every day with one of these enormous ships right in your doorstep, and getting to climb all over equipment and work with this stuff and get your hands dirty in your boiler suit and your hard hat is something I really enjoy doing. Another thing that's really lucky is some of the opportunities that you get to take within BAE Systems as an engineer. Sophie, if you could slide to the last one for me. And one of the things I got to do as an engineer is participate in a trip on HMS Fourth. So the left photo here is a picture of HMS Fourth, which is the first in class of the offshore patrol vessels that we recently finished. It's one that I worked on as a graduate, and I worked on the remaining sister vessels, once I'd finished the graduate scheme as well. Once we'd finished the ship and handed it over to the Navy, they then asked us if we wanted to send over a small number of staff who'd worked on the project as Navy guests to travel with them on a trip from Portsmouth down to Gibraltar, which is at the bottom of Spain. And I was lucky enough to be offered the option to go on that trip as an engineer. And we had a great time. I got to see what it was like to see the ship that I had built and taken a part in building actually in service on the water, doing what it's supposed to do, run by the Navy. It was a fantastic week. I got so much exposure, and I got to see the product that I'd helped build and design on paper in real life, doing what it's supposed to do. So we did a lot of maneuvering tests, so we did a lot of rolling, donuts in the water. We went up to full speed. They let us go out on the ribs. So the top centre photo there is a picture of me really happy to be out on a rib in the water. And then we go alongside the ship, and the crane lifts us up back onto the vessel, and we stay on there. They showed us how to use the firefighting systems on ship, which you see in the top right-hand corner there as well. We got to test all those out and just generally see how the ship operates once it's in the hands of the person who asked to buy it. So it was a really brilliant opportunity, and as a designer, it's a great way to see what you're building getting put in use and how valuable it is to the person that you're building it for. So I think I'll tie up there. I've probably gone on a wee bit longer than I was supposed to. And the key piece I would probably give away based on what I've just said is to never let an opportunity pass you by. I think that's one of the most important things you can do, is take up any opportunity that comes your way, because you never know where it might lead you, and what comes out of it may be something that can help shape you into the person that you are. So on that note, thank you very much for listening to me, and I'll have to pass back to Sophie for any questions.
Thank you so much. That was amazing and so interesting. And we've got so many questions, so I'm so excited to ask them you. So we'll start off with, someone has asked, roughly how many ships do you think you've helped to build?
So for going down to the very small details, I have probably helped on 15 vessels. So 5 offshore patrol vessels, 8 are, so the Type 26, there's 8 of them. So once they're all fully built, that I will support the design for 8 of those. And I helped very, very small part on the aircraft carriers. Once we get the Canadian and Australian vessels built as well, that will total 32 Type 26 ships. So there's a lot of vessels there that are impacted by my design.
A lot of work.
Yeah.
We've got plenty more questions. Someone has asked, have you travelled for your job before?
Not anywhere exotic yet, unfortunately. So as an owner of a package on the Type 26 program, I get to go and visit my supplier. So because we're a ship builder, we don't necessarily build every single component on the ship. We buy a lot of equipment in. So we buy our engines in, we buy our cooling systems in, we buy our combat systems, so guns, weaponry, we buy all that in. So I get to go and visit my supplier when any of their equipment is ready to deliver to myself. I'll go over for what's called a FAT, factory acceptance test, where I go to the supplier's warehouse, see the manufactured equipment and then test it. So at the moment, I've only managed to get down south for that. I am hoping to get over to France before the end of the year to go and see some of the shaft lines, but fingers crossed with COVID that happens. There was a lot of trips cancelled last year as a result of COVID. But
I can imagine. We'll all keep our fingers crossed for you.
thank you.
We've got another one from Akel Primary School, and they have asked, are you the only person in your family to be an engineer?
Actually, no, and it's quite interesting. My uncle worked in the shipyards, so it's another thing that kind of tied into it quite nicely. But my mum and dad were both pharmacists, so when I came along and said I wanted to be an engineer, that was a bit of a railroad for them, a derailment for them of what they thought I was going to do. And then luckily I managed to get my brother and sister both on site. So my brother is a mechanical engineer and my sister is a biomechanical engineer. So three engineering children in the family, so we'll look to continue.
That is great. That's a brainy family. We've got another question. How long does it take, do you think, roughly, to make the ship from start to finish?
So it very much depends on the size of the project that you're looking at. The Type 26 project is one of the most complex and advanced designs we have had to complete so far. As far as I'm aware, I think the design now has been underway for approximately 10 to 12 years. And the dates for vessel acceptance, which is sign off and handover of the ship once it's finished, for ship 1 is, I think, about 5 years from now. So already that's 15 years just from start to finish of one ship. We then have a further 7 ships just for the Royal Navy to finish. So it takes a long time to get a ship out. It's one of the biggest things and most complicated things that you can build.
It is a long time. I mean, I'm sure we would all assume it would take a long time, but 15 years is...
Yeah. Fortunately, it's not as quick as building a car and turning it out in a production line, but it just makes the job more interesting.
How old were you when you first became an engineer? Were you one straight out of uni?
Yes, so I've always been one. I've very much been one to get as much education as I can. So as soon as I finished school, I think it's a little bit different for you guys in England, but for me in Scotland, I finished school at 17, just turned 18 when I joined university. I was then 5 years at university to get my master's degree. So I was 23 when I started at BAE Systems, and I'm now 29. So it's been 6 years of very, very interesting work.
I love it. And we've got another one. Who or what inspired you to become a mechanical engineer? Did you have any previous career paths that you thought you might have took on, but then suddenly you thought, actually, I'm really enjoying this?
That's quite a good question, actually, because I'll be honest, I'm very jealous of you kids just now being in the position you're in and having these opportunities to learn about what an engineer does, because when I was your age, never really got told at school what an engineer was. It was just a very vague term to describe a lot of people's jobs. So I didn't really know what an engineer was, even right up through high school. I remember applying for engineering degrees and still not being entirely sure what that would involve as a job. I just knew that you had to be good at maths and you had to be good at physics, and for me that was something I loved doing anyway. In my spare time, I play a sport called shinty. It's a Scottish sport. It's very similar to hockey or Irish hurley, if any of you have heard of that. And one of the girls that played in my team, she was from up north in the Highlands, but she played in Glasgow because she went to university in Glasgow, and she actually did the degree that I ended up doing. And part of the reason that I did it was because I was inspired by how excited she always was when she talked about her degree and what her job was. She ended up working in the aircraft industry for Rolls-Royce as a test engineer. So she was telling me about how she was throwing frozen turkeys into jet engines as part of the tests and all that for aircraft robustness. So for me, that sounded so fascinating at the time as a school student, and it really helped me get to where I was.
And obviously it's really important to enjoy your work and the field you're in. So it's great that that little pep talk, and got you going to where you are today.
Yeah.
That's great. I've got a very interesting question now. I'm hoping you might be able to answer it. And the question is, how do you plan to make the ships safe for the environment?
So that's a really good question. And obviously it's very topical just now, given COP26. I think specifically in Navy warship design, it's very difficult to try and appease a lot of environmental regulations that we're trying to force. We do have to abide by environmental regulations that are in place. That's not to say that we don't. I just mean from a carbon footprint perspective, there's a very limited amount that we can do to be both environmental and also provide the Navy with what they need to have a successful warship. But things that we would look at, so I think in 2011 there was some environmental regulations in place to do with emissions. So part of the Type 26 design, which is a very new piece of design, is that we have installed catalytic converters within our exhaust systems. Those catalytic converters take the exhaust gases that are released from combustion in the diesel generators. They essentially cause a chemical reaction which removes hazardous sulfuric acid gases and nitrogen oxide emissions. So there's a number of very toxic gases that come out of engine combustion, very similar to what happens in car exhaust systems as well. And as part of the marine industry's response to climate change, they put in this regulation where we have to install these catalytic converters to reduce our air pollution outputs from burning fuels. So that is something that we've implemented within the Type 26 frigate in order to reduce our overall air pollution emissions. So we're trying where we
can. We've got so many questions coming in. So we've got another one, which is, do you think that your journey to being an engineer has been particularly difficult in any way because you are a woman?
I love that question. I love talking about it as well. It's funny. I would say not massively, but in some ways yes, some ways no. So being a female engineer, obviously I'm a minority, but even more so in a shipyard in Glasgow because it's very traditionally male dominated. If you met anyone in Glasgow, there's a very high chance that whoever you meet has a relative, an uncle, a dad, a great granddad who worked in the shipyards. It employed a huge population of the Glasgow population at the time. So already I was outnumbered joining the shipyard, but at the same time there's a lot of respect from the guys in the production team. They respect you as an engineer because of the knowledge and capability that you bring to the business. I am trying to use being a woman in engineering to my advantage now. Things like this here, I've won Scottish Engineer of the Year. So for me, I'm trying now to use it as a platform to promote women in engineering, hence the reason I'm here, and to try and give more visibility to women in engineering and show that it's a normal thing and that it should be promoted much more positively. So yeah, I haven't crossed any adversity, but I definitely am aware that I'm a minority within my business as a female in engineering. But it makes me quite proud to know that I am a minority, but I can still hold my own and make changes within the business for the positive.
Definitely. I mean, even as a woman myself, it makes me proud to see a female engineer in the field. It's really amazing. So the girls watching as well, you know, anything is possible, and if you love it, you've just got to go for it, which is great. Why did you choose BAE Systems?
Oh God, honest answer, it was the first place that gave me a job, which sounds absolutely terrible, and I hate to promote that amongst everyone, but I was looking at job offers for aircraft industries down south, and to be honest, it was kind of a combination of location for me and it's kind of a balance between what I wanted to do and where I wanted to be in terms of coming out of university. I stayed at home in Glasgow when I was at university to save myself some money, and then the job offer came up to work in Glasgow, or there was somewhere down very remote down south that I wasn't so keen on. So I actually took the job at BAE Systems because it would be somewhere locally feasible for me. It's a new challenge as well. It was something totally out of my comfort zone, and at the end of the day, I don't regret anything because I've come such a long way. I've learned such a vast amount, and I really love what I do. So although it wasn't necessarily a specific choice at the start, it's definitely something that I'm glad I've done, to be honest, to get where I am.
Good. And obviously you've stayed there for a while now, haven't you, as well? So yeah, fab.
Yeah.
Let's see, so many questions to choose from. We've got, what was the smallest ship that you've worked on, if you can tell us?
So the smallest one was the offshore patrol vessel. It's only 90 metres in length. That's about the length of a football field, which is large in comparison to, you know, a car or whatever or anything like that. But it's one of the smallest vessels that we have. Well, sorry, one of the smallest vessels that I've worked on. So yeah, that's definitely the smallest one.
What would you say your favourite part of the job is, this in total?
I think one of my favourite parts is, well, there's probably two things that I can say. One thing I love doing is solving problems. Even in school, before I knew I wanted to be an engineer, I got a great sense of satisfaction out of solving the problem. When you got to the end of a long sum or a calculation and you checked the answer and it was right, that was a great, you know, I've used a lot of principles to get here. So going through university, learning all my engineering principles, Newton's laws, all these wonderful things, physics related, they're all things that I use on a daily basis when I'm doing all my analysis and calculations, and getting to the end of a problem and either verifying it or getting it checked by somebody and knowing it's right gives me a great sense of satisfaction knowing that I've solved the problem. And then secondly, just being in the shipbuilding industry and working in a live production is a great thing to be doing, because you get involved with the product in real life and it's right there in front of you. You get to be immersed in it and live it day by day. I love being in my overalls and my hard hat and getting on ship and really working alongside the guys that are actually doing the building and helping them get the job done. It's great fun.
We've got this is quite a funny question actually. So we've got someone asking, do people always ask you to help fix their cars?
Actually, no, but you know, that's a funny question because I get a lot of people ridicule me when I can't fix my own car because I'm an engineer. So I get a lot of people make fun of me because I can't fix my own car. But luckily, I've not been asked to fix anyone else's. my partner is also he's a marine engineer, and we're both as useless as each other trying to fix cars. So our poor mechanic is constantly got one of our cars in his garage to fix. But yeah, no, unfortunately, no, I can't do any car mechanics at the moment.
Great in the shipyard, just not with your own car. How many hours do you work in the week?
So one of the great perks of working at BAE Systems is that we work on a flexible contract. So I'm contracted 37 hours a week. And well, pre-COVID, we had to set core hours during the week, so sort of 10 to 12, and then afternoon hours of 2 to 3, over which we worked. But aside from those core hours, you are free to work your 8 hours a day whenever you want, and that allows you to manage around any dental appointments, hospital appointments, or any childcare that you need to manage. So the company, BAE Systems, is really good in that respect, and identifying that people have different needs, and the working hours allow you to meet those needs and still get your job done. So, yeah.
And during, obviously, it's been a crazy year. During the pandemic, could you continue? Because I assume you'd be classed as a key worker.
Yeah, so day one, as soon as lockdown closed, it was continue as normal for the office staff because we could work from home. So we had to take our laptops home. You'll see I'm in my spare bedroom at the moment, which looks like a gaming zone for my partner's equipment. So office staff were tasked with working from home, and because we had the capability to work from home, we continued as normal. I think the yard was shut for about 5 weeks until Boris Johnson allocated us as essential workers for defence purposes. So I think there was 5 weeks shut down until we were back up and running, with a huge amount of measures put in place. So we were kind of part-time working for the production staff so that we could manage numbers and social distancing within the yard, and allow everyone to still be safe. So yeah, we've still been working full time since the pandemic started last year.
And we've got this question I love. Why does a boat float and how?
So you're asking the wrong person. That's for a naval architect. So a boat flows on the basis of something called Archimedes' principle. Archimedes was a Greek philosopher, I believe, I might be wrong. From way back long ago, when the Greeks were very, very smart people. The reason that a boat flows is because if you imagine a ship, also a little fishing boat or something, or a kayak that you're in, the empty space that sits in that kayak when you're sitting in it, that displaces, so it pushes the water out, and the amount of water that it pushes out creates a reaction force on the bottom of the hull, on the bottom of the kayak or the ship, and that is what's called the buoyancy force. If that buoyancy force is greater than the weight of that ship, then your ship will float. If it's too heavy, if you fill it up, it'll sink. But if it's light enough, then you've got enough displacement of the water and enough of an upward force caused by the water to support it in a stable flow state.
Well, I'm glad I've learned something there.
Please look up Archimedes' principle because I've probably not explained it to the best.
We'll take your word. We've got, do you find that your job can be fun even though it's quite serious?
Yes, the job can be very serious at times when under pressure, but I do love my job. People would probably describe me as quite an amicable figure in work. I spend most of my time laughing, mostly to stop me from crying, but I do laugh a lot. I do enjoy. If you're not having fun at your work, then you should be doing something else. Is kind of the principle that I will apply. So as long as I'm enjoying work and enjoying the people that I'm around and working with, then it keeps me happy. So yeah.
I love that. And I think that probably leads us nicely on to the next question, which is, if you could give one piece of advice to kids for them to do engineering, what would it be?
Well, yeah, you're probably right, Sophie. I think, to be honest, it probably wouldn't be anything technical related. It would probably be what we just touched on. Make sure it's something that's going to make you happy. There's nothing worse than doing a job that you don't like. Obviously, the job comes with its stresses and it can be difficult at times. But for me, that's just try and turn it into a positive where that becomes a challenge, and it gives you an opportunity for development. And on that as well, as I said before, do not let any opportunities pass you by, no matter what those could be. As I said, I got to go and study in Australia for my third year at university, which is something that I always knew I wanted to do. So I used to study abroad program to take up that opportunity to go and travel around that side of the world. I got to go to New Zealand, Fiji, Thailand, Singapore, and all around Australia as well. In my second year of my course at Mechanical Engineering, I had to take a flight test course where I flew on a glider, which is a engineless aircraft. It's got the long, thin wings, and it kind of floats around before it gradually glides down to the ground. So I got to fly in one of those over a course of 3 days, which was absolutely incredible, such a wonderful experience. And all these things came up to me as opportunities, which I then took to get experience out of them. So definitely take opportunities as and when they come, and make sure that you're doing something that keeps you happy.
That is lovely, and I'm sure everybody watching will be taking it on board and studying extra hard in their favourite subjects. So I think we'll do one final question, which can be, has your job ever been dangerous, or have you ever injured yourself at work?
That's a very good question for me specifically. Working in a shipyard, it's a very dangerous environment. It can be a very dangerous environment. There are a huge amount of hazards on a daily basis, and it is the number one priority of BAE Systems naval ships is to apply a safe system of work. And the key mantra that BAE Systems apply to all of us is that we every day go home safe. We all have families, we all have friends that we want to get home to. So the most important thing that we do in our day job is ensure that we are being safe for both ourselves and others around us. So on that basis, I've not been injured significantly yet. I may have clocked my knee off a bit of scaffolding before, but it's purely my own doing. But other than that, the business that I work for puts in a lot of measures in place to ensure that I am completely safe in everything I do. I wear PPE, I wear hard hats, I wear steel cap boots, I wear protective glasses and ear defenders to make sure that I'm as safe as possible. If I am working at height, I wear harnesses, so I have to wear a harness and be clipped to the structure that I am up on, which shows that I'm properly protected, and I always have to be up to date with my training, safety training, to ensure that I am aware of the hazards that are around me in the shipyard and that I am compliant with the safety process.
So nothing too dramatic.
Actually not.
Well, that's good. Thank you so much for your insight today, for your job. It's been absolutely amazing, and we are so grateful, obviously, for your time as well. We know you're very busy with the hectic schedule, so thank you so much for that. Thank you to everybody for joining us today. I hope you've been inspired, and who knows, maybe somebody watching this will one day too be building the next generation of Navy warships. Remember, everybody, this interview is part of a series that's on every Wednesday at 1:30. So at the same time next week, we have Mr. David Ridland, who is the Technical Director at Soapworks, and he will be challenging our thoughts and opinions on palm oil, as he encourages the use so long as it is sustainable. So one more time, a round of applause for Alana, because it was great. So thank you so much for that. And a pat on the back to everybody for all the amazing questions. And we hope to see you all next week. And thank you so much for joining. Bye.
Thank you. Thanks, Sophie. Thanks, everyone.